Our inquiry project focuses on weather and climate. So we picked the phenomenon of flash flooding. We decided on this phenomenon after thinking about some of the experiences our students would have had with flooding in the past year in Pittsburgh. Flash flooding is also very common in the areas surrounding the city due to the large amount of rivers and streams we have. So a flash flood for our purposes will be defined as any flooding that begins 3 to 6 hours after a heavy rainfall. For this unit, students will have to have some general understanding of weather patterns in Pittsburgh, such as heavy rainfall. And we're going to connect that to their new learning about flash flooding. This unit is designed for third grade students, and the objective is to have students understand flash flooding in our communities to the point where they can begin to engineer solutions to solve these problems we all face in a way that applies some of their scientific learning. Our standards for environmental literacy are to develop a model to demonstrate how local environmental issues are connected to larger environmental issues. The science standard is to represent data in tables and graphical displays to describe typical weather conditions. And we have two technology and engineering standards, the first being to design solutions by safely using tools and materials, and the second to make a claim supported by evidence about the merit of the design. To introduce this topic to students, we're going to start with a picture study and a knowledge, would like to know, and I've learned part. So students will be shown these two photos that you can see on the slide from flash flooding events in Pittsburgh. They're going to work in small groups to talk about some things they already know and pose potential wonderings. The main question we want them to come to is, do you think there's a way we could have prevented the damage caused by flash flooding? This unit has 3 major activities and also a technology integration. So for the first of the major activities, we have students creating an uneven clay surface that will act as a hilly or mountainous area. And we're going to replicate the experience of heavy rain by dropping water onto this model. Students are going to map out where the rain pooled and what path it took to get there. In the second activity, students are going to be using data about rain in Pittsburgh to make bar graphs and interpret the data to come to conclusions about when flash flooding may be most dangerous or most likely to occur. And for the last activity, before the technology integration, students are going to be very playfully designing with 3D materials a structure that can be saved from flash flooding.
For the student engagement, the students are creating the uneven clay surface to show where the rain pooled, analyzing data from Pittsburgh's rain to create a bar graph, and students will plan and design a house and test it to see if it could withstand flash flooding. And then our final artifact would be a lab journal that just has information about these activities that they did, and then also the technology integration. The formative assessment would be observing students as they create the uneven clay surface and using their strings to represent the rain, and then drawing their findings on graph paper, and then providing feedback during that process. Same with the planning and designing of the house. And then the summative assessment would be reviewing the student's final bar graph to represent the data from Pittsburgh's rain, and evaluating their house and design and testing results, including their lab journal. So for the lab journal, I was just picturing like a blank composition notebook that they're able to add information as like the year goes along. So some pages I would include was a little information section about what is flash flooding, and they would have to write down the definition, why it occurs, and stuff like that in their science notebook. Their flooding model, so when they create their uneven clay surface, drawing a picture of it, and then what they observed as they were creating it. And then since the bar graph was created online, I figured they could either print they would print and glue it in the notebook with a description of their findings. And then their plan would be in their notebook, their observations, results, and then things they would change for the future. And then to incorporate a little bit of their technology integration in their science notebook when they are using the website Don't Flood the Fidgets, students will have a drawing or a printed out screenshot showing their city, and then they could add information about what protected their city, what didn't protect their city, and this can kind of be scaffold to fit the needs of different groups of students. So I don't know who exactly this would be for, but if they needed a little bit more support in writing their observation notes and stuff, I would have a slide on the board with questions they should be answering and wonderings they should have.
Okay, so for teacher engagement with this project, I feel like a lot of the teacher's role is just to guide the investigation and allow students to kind of come up with a lot of the information. But I outlined for the 3 activities, what that role might look like. So for the first activity, I feel like a lot of the teacher's role will be to circulate and observe while students are dropping the water on their uneven surface, and they might ask open-ended questions like, how do you think the shape of your surface will affect the water flow? And other open-ended questions to get some like investigating going on. Prompt different observations like, how did the water move across the surface? And then at the end, you can encourage discussion. You can even ask the key questions that were outlined earlier by Amanda. For activity 2, I think it would be good to connect to what they learned the day prior. And then like facilitate a discussion about the information they see. So like, what trends do you see? What month may have had the highest rainfall? And while students are creating their bar graphs, you can monitor and provide feedback and then allow for group sharing. And then activity 3, introduce the scenario and kind of engage with it and begin the brainstorming process. Start asking questions like what materials and design features might be needed. Give feedback as you walk around. And while they're testing, it's really important that you're guiding and encouraging observations. So like, what do you see? And then once again, kind of come back and have a reflection or discussion. So like, what parts of your design might have worked well and what would you change for the next time? And then for some of the student challenges that I came up with, I thought maybe interpreting data. So it's important during that second activity that you're providing guidance on how to read and represent data, time management when they're trying to design their structures. So make sure you're setting a clear time limit for each part of the activity and provide reminders to stay on track. Brainstorming, students might get kind of stuck. So provide prompts or guiding questions to encourage their creativity and working collaboratively. So make sure you're like, if you see kids having trouble, like try to facilitate their discussions and ensure and encourage everyone to participate in their groups.
Okay, so for the technology integration, students will be partnered up and they're going to work on a game called Don't Flood the Fidgets, where students will build houses, apartments, inlets, wetlands, roads, levees, canals, and other structures to keep their town safe from the rivers. This project will include technology integration. It should be engaging for all the students, but it'll also use their math skills to make sure that all the structures that they're building remain under the budget that they're given in the beginning of the game. There are 3 options in this game: island, river, and peninsula. But since we're talking about flash flooding in Pittsburgh, the students will all be doing the river city. The students will have 1 class period to complete the activity with their partner. Once they have completed building their city, we're going to print out a copy of each final city, and then they'll be asked to put it in their lab journal. For the writing portion of this project, they're just going to be asked to write a 1-page journal entry about the experience, the tools, the structures that they chose for their city, and whether or not the city got flooded or not. So we chose this project so that students can visually see the structures that protect cities from flooding. Students will be able to collaborate to find the best tools necessary to keep their city and its inhabitants or the fidgets safe. By like applying these like tools and structures in the game, they'll be able to gain a deeper understanding for the tools that protect cities from flooding. And during the project, the teacher will be walking around, asking guiding questions, and supporting students wherever needed.
And here's the rubric for the lab journal and like the final tech project. It just talks about there's 4 levels that they could be at: needs improvement, satisfactory, good, and excellent. And then it talks about the different activities and what we would expect from their journal entries in their lab journal. So in order for a student to get an excellent, the notes would have to be complete, and then they like show understanding of flash flooding and what we're learning about. And then their drawings would also have to be clear and detailed. The bar graph would have to be accurate. The design for the house is creative and practical, and it uses their learning to create it. And then when we think about how we would change it for the future, the changes would have to be like thoughtful and based on what they're observing and what they learned about through that experience. And same with their journal entry on protecting the city.